All right, we're going to go ahead and get started. Thank you everyone for joining Zometry's webinar today. We're going to be talking about the top 10 considerations you need to have in mind when scaling up with injection molding. So first, let me introduce myself. I'm Serena, and I'm on the marketing team here at Zometry. Here are a couple of quick notes before we get started. Please submit any questions you have throughout the webinar in the question box for our panelists to answer at the end. I'll be monitoring them as they come in, so feel free to submit them at any time. After the webinar, we'll send you the webinar recording, so if you miss something, don't worry, it'll be available on demand. And at the end, please stick around. We're gonna give you a discount code for you to use on your injection mold quote. So first, I want to introduce your first presenter, Greg Paulsen. Greg is the Director of Application Engineering at Zometry. He has spent over a decade working with engineers on custom manufacturing projects using CNC machining, additive manufacturing, sheet metal, urethane casting, and of course, injection molding. Prior to Zometry, Greg worked in product development with a focus on ruggedized electromechanical systems. Next is Kyra Stawson. Kyra is our technical sales engineer for our injection molding division here at Zometry. She graduated from Penn State Behrend with a degree in plastics engineering and has a background in automotive manufacturing at Toyota. Her passion lies in the design stage of injection molded parts, which makes her a valuable asset to Zometry customers to help them take their projects from start to finish. And finally, we have Kyle Adams. Kyle is a senior injection molding engineer at Zometry and has 14 years of rapid manufacturing experience, which includes quick turn prototype injection mold tooling from his time at Eccentric Mold and Engineering and 3D Systems. He excels in consulting on customer projects for a variety of industries and specific end environments. So welcome to your presenters, and I'll pass it over to you guys.
Awesome. And hey, this is a great crew today with Kyra and Kyle beefing up the technical side of injection molding. We're definitely here to talk molding and to help answer your questions. And again, very special thanks to Serena. Serena does almost all the communication you see from marketing. If you're getting emails, learning about case studies, she's behind the scenes and all that. And I did want to pitch that out because we make so many awesome parts at Zometry. And if there's ever is a chance, if you're working with us and you want to talk about those parts, we're always happy to do case studies and highlight the achievements if you're willing to share. So just want to give that little promo as we have it here. But yeah, today we're going to be talking about injection molding. So we're talking about some of the top 10 considerations that you may have when you're scaling up and moving to molding, whether it's a 3D printed project to molding, or you may have a traditional manufacturing need and you're moving up to molding here. But before we start, I do want to talk a little bit about Zometry and kind of what we are, what we do. We are a single platform to make parts and make it very easy to make parts. So you as a designer or engineer or even procurement and sourcing, you need to get parts custom manufactured. We have a online platform where you can upload your technical data, get it priced out in a variety of processes. We're now over a dozen processes through our platform that we can quote out for you, including injection molding, but also things like 7 types of 3D printing processes, many of which instantly quote, and then you buy, and we help take care of that whole supply chain aspect of it for you. So we're all about making it very simple to source custom parts in a technology-driven platform. And like I said, we offer a lot of technologies, including, actually, I should add some of these more scalable ones like die casting and stamping as well, because we just opened up our digital RFQ platform. But machining is one of our bread and butters that we do all the time. That's 2-spec machining, sheet metal fabrication, plastic and metal 3D printing processes. We also provide urethane casting. So if you're looking for those quantities kind of between 5 to 50 or 5 to 100, urethane casting may be suitable for a end-use product need. and then of course injection molding. So this is something that can truly scale, whether you're looking for the low hundreds or the tens of thousands or the hundreds of thousands. Injection molding is one of the best ways to make parts in high production at low cost per part. So that's what we're going to be talking about today. As Serena noted, any questions that you have about Zometry, about our platform, and anything that we're talking along the way, yeah, please use the questions tab on the GoToWebinar platform. We're going to try to address those at the end of our talk. We're going to save a lot of time for that. But we're just always excited to help answer those questions. So Zometry's platform is really unique because it does allow you to upload technical data and kind of spin the CAD and start configuring your part directly online. It's one of the most simplified ways to communicate your technical needs. And for some processes, it's a quote and done, quote and buy experience. And for other things like molding, it may be the beginning of the conversation, but you're creating that template to help guide us in where you want to be with your parts. I'm going to just go drive the site real quick here, show you a little bit about Zometry's website and our platform, because I know also you may be in different stages of your product development process, or you may be working with a technology that's new to you, like molding. Not all of us have done injection molding projects, so sometimes it may be worth looking at our design guides or resources. So this is Xometry.com's website here. You can see that we have a variety of manufacturing processes that you could go and either start a quote immediately or learn more about. I also recommend, if you're in that design phase or you're looking to build a product using a different technology, check out our resources tab at the very top here. And under resources, you could get some really great expert design tips. I really like going to the design guides page. And for every process that we offer, we have a design guide available for that. So obviously today is about molding. So if you want to learn about molding, check out our injection molding design guide. Very useful guide. It's going to go over a lot of the topics that we are talking about today in a little bit deeper detail. And actually, let me go and bring us to the quoting. I'm going to click get a quote here to show you a little bit about how you would get a quote. So when you click get a quote, it'll take you to Xometry's dashboard. For molding and most of our quoting efforts, you're going to actually start right here. So we can take most native files from your direct CAD platform. So if you have a solid part or IPT, we can take those directly upload. We can also take step files. They're kind of like the PDF of the CAD world, and SAT files, PRTs, anything that has that solid data. Just to note, for 3D printing, we can take mesh files like STL files, but we cannot use STL files for things like machining or molding because you have to make tool paths around it, and those mesh files just don't have enough data to really appropriately cut the metal or cut the tools for those parts. I'm going to go ahead here and show you a little bit about the quoting engine. We'll do this live very quickly. Let me grab a piece that I can mold. So I got a little, let's see here. Let's grab this piece. Gonna move through. I'm actually just gonna skip this through to go straight to the instant quote platform. The reason why I'm showing you this is because you may, as you're developing parts, as you're moving to molding, one of the first things you may be doing is going through prototype stages. So you may be using different types of processes like 3D printing to make your parts, and it couldn't be easier. So in fact, I'm already quoted. I'm already ready to buy. The second that these parts, your part is uploaded, it gets interpreted, and it will actually price out in the cheapest process if you haven't selected a process. So in this case, this part here is only 13 bucks if you're making it using a process like HP Multijet Fusion. So 3D printing that out of a nylon material. I can click on this even further and start to specify my quote. So if I'm going beyond prototyping, getting a weird little, I think this is a GoToWebinar little glitch here, but if I'm going beyond prototyping, I can also go and change my process here. Let me try to move this through. Anyways, I do have a 3D viewer right there. I just not seen on the preview screen. So I can move through my different 3D printing processes. So I have everything from like carbon DLS to FDM. Multi-Jet Fusion makes parts in nylon materials. We also have SLS, which is a great go-to for parts out of nylon, and SLA if you're looking for a very nice detail material. So I could go make this in Somas Evolve. You can see your pricing updates automatically online. If I go and change my quantities as well, the pricing will update automatically. And I can further specify my parts. So I can add things like, threads, tapped holes, part markings to this part. If you're looking to move to injection molding, it's always good to have that conversation early with us. So even when you're prototyping, it's definitely worth starting the conversation with molding. We know that your part's going to iterate through. If you choose injection molding, you can start by choosing a material that you may want to go. So I have HDPE here. You have a variety of color options, and if you don't see the color you want, you can always choose other and type in what you need. Fillers like glass fill is very common for us. Additives like a UV stabilizer, you could add those. And we're really interested in some of these options, like are you looking for a prototype or production tool? How many units are you looking to make? That's going to help start that conversation. Like I said, this is the beginning when we talk about molding, because once you have all the information in, you request a manual quote, and you'll probably actually get a call from Kyra in a second here on that. So I wanted to show you this very quickly. We'll go into more details later, but I think I want to talk about the top 10 considerations for molding now. But just want to show you that on all-in-one interface, we have so many technologies available for quoting and interpreting your part. And again, some of that's automated with instant quote, but we also have the engineering backing to talk through and get deeper into the conversation about your manufacturing project here. But all in one platform. And by the way, the fulfillment end of this is capable manufacturers. So Zometry, we're actually networked with over 3,000 manufacturers domestically and about 4,500 total globally. So we do have a wide variety of shops, whether those are shops that could do low volume production all the way up to high volume, high spec work. We're able to match these through. So let's talk about that a little bit more. Let's talk injection molding. All right, so why do we choose why do we choose molding? From above, like it scales. We find that it's the cheapest process at scale. In fact, when you're looking around, probably everything around you right now is a molded product. Like everything plastic around you is probably a molded product, unless you're at my desk and you have a bunch of 3D prints here. It's consistent, it's repeatable, so you get a consistent product part to part. It can be used for low volume production, but it definitely excels at that mid to high volume needs. And you have a huge variety of materials, colors available, as well as custom cosmetics, because it's just such a tried and true technology for production of parts. For these top 10 tips that we're about to go through, you just want to keep in mind why these tips are available. So when we are talking about injection molding, we are making a tool. So this is a metal assembly that essentially has a cavity in the shape of your part. And we're going to be injecting molten plastic into that. It's going to cool and it's going to have to release from that cavity and continue to make parts through. So when we talk about injection molding, it's not just a direct to part process. It is all about how do we specify and make that tool to make your part to your specifications in a repeatable and consistent fashion. So there's a lot of considerations, and that's what we're talking about today. So just understand everything about this is about how can I flow plastic into this cavity and get this part exited out of the tool right over and over and over again. So this is where I'm going to send the mic over to Kyra and Kyle to start going through some of the top 10 considerations when scaling up. And Kyra, I think you're up to bat, right? So we're going to be talking about some of these critical strategies to optimize for part design first. So let's go with number one.
Awesome. Okay, let me make sure. Okay, I'm good. So there are a lot of factors that go into injection molding, like Greg said. It seems really simple when you're thinking about the process, just injecting plastic into a cavity and ejecting the part, right? There are several factors that go into that and making a good quality part. So first and foremost, uniform wall thickness is critical. With injection molding, a molten plastic tends to shrink at different rates. So if there are different thicknesses, you're going to see that reflected on the part. So what happens is either one of two things typically. Number one, you can either have this result in a sink mark, which is seen in that little image there in the upper right-hand corner, which is just an indentation. Typically, it's non-detrimental to the function of the part, but it is not aesthetically pleasing. So we want to avoid this if we can. You know, but in applications where maybe it's not so critical, it's okay to have that marking on the part. We can get away with it. That's fine. If you were to go flip over your trash can or something like that in your office or room, I'm sure you'll see what I'm talking about here. On the other hand, you can get a void in a really thick area too. And that can be very detrimental to the part. So like Serena said in the beginning, I actually came from automotive, and the process there is you run a plastic bumper and then you put it in a paint oven, it gets painted and it's cured. If a void is exposed to heat, typically that can expand because it's gas in there, it can expand and protrude from the part, which obviously isn't a good part, good quality either. So to improve that design, you would want to core out that feature. In addition to these two defects, warp could occur as well if there are, you know, difference of thickness in the part, across the part per se. So utilizing the features of coring, you know, or shelling out the part or ribs is critical to mitigate these risks and maintain that uniform wall thickness in an injection molded part. Also, you know, keeping this in mind early on whenever you're doing prototyping is critical, because if you kind of design yourself in a corner per se, and you really like your design, but it's not suited for injection molding, and that's your long-term process, then we kind of have to step back and start from square one. So keeping this in mind early on is critical in your designing journey. So that is uniform wall thickness. Second is undercuts. Undercuts are pretty complex features that typically require some sort of special tooling called a sign action in the tool. Now, with our partner network, something that kind of differentiates us from a lot of others out there is we can use our capabilities and utilize our capabilities to find somebody in our network that can handle these types of features. So these are really simple for us to achieve. Now, what that means is whenever an undercut is there or you need a sign action, typically there's a feature that is perpendicular to the parting line, meaning it's perpendicular to the direction of draw. So you can see in the first image there, first and second image for that matter, there are red areas. That is an undercut analysis done in SolidWorks where everything that is not in the direction of draw is considered red or an undercut. So that is okay to have designed in the part, but just understand that there will need to be a sign action or some sort of feature to achieve that feature.
Yeah, and so I think it's important also when you're talking about undercuts. I mean, if you do have side holes, it's very nice to have side holes on that one face if they're all in the same direction. And that's going to go into the next side here, but that allows us to tackle those at the same time with one extra action versus having multiple actions or hand loads.
And then before you switch over to that slide real quick, the bottom image there is considered a pass-through core. So if you're doing a typical snap feature like that, the first image is doable, however, it is more complicated. So an easy way to get around that is having a pass-through core where there's actually a hole underneath that feature, so you can just come up from the bottom and capture that surface there with the other half of the mold. So that makes it really easy. There are ways to get around it, but again, it's not impossible, but it does make the tool a little bit more complex.
Yeah, and that complexity can add cost. So, you know, a lot of times, like when you're mitigating a side action by using a pass-through core, you may be reducing the cost of your tool by potentially thousands of dollars, depending on the complexity you're removing there. All right.
Okay, and 3, draft. So we have thickness, undercuts, and drafts. Those are the 3 kind of main features that you want to look for in a good injection molded part. So draft, the simple purpose of draft is to provide ease for ejection of the tool. So I kind of use a silly analogy. If you imagine a Chinese finger trick where you have that little game and you can't get your fingers out unless you squeeze the center and allow air to come in there, that kind of applies here in molding as well. So if you have vertical walls on a part and you're trying to really pull it off the mold and it's creating a vacuum on the inside, it's going to be really, really hard to do that. So we apply this slight angle to the walls to allow air to get in there and pop it off the tool. Typically here at Zometry, our minimum draft requirement is a 1/2 degree, but we've circled 1 degree there just because a little bit more is better, but we can get below that if we have to. And then of course that can adjust with surface finish as well, which Kyle's going to touch on later. The rougher the surface, the more draft that will be needed. So if you don't have that, you could definitely result in drag marks or scratches on the surface of the part, which is going to result in from kind of scraping it off the tool.
Yeah, I've seen some of that sometimes in like speaker grates and things. Like if it's just through pins, you may see little scratch marks because it'll pull on each one of those. Each one of those pieces. And when we talk about this uniformity, undercuts, and drafts, which by the way is Kyra's like this is her conversation every single time we're talking molding here. But um, what's beautiful about this is most basic CAD programs that you have these tools available right away. That's usually not an extra cost. So I happen to have SolidWorks on my computer, but I know you could do this in Inventor as well. But there's usually these, wherever you're going to find your evaluation tools, like measure tools, there's probably going to be a wall thickness analysis. And that's something that you can use to see the deviation between the walls and understand that uniformity. There's almost always a draft analysis, so you can actually click a face and it'll essentially simulate that direction of pull and tell you where you have zero drafts or other features where you may have to incorporate draft to it. And the same with undercuts, where again you simulate that pull, and as we showed in that previous image, basically the bright red features are going to be the things where you're probably going to need another tool approach. So you need to add complexity to the tool, which isn't bad, but it has to happen if you need that feature. And it's very good to know that as you're in that design phase.
Right.
In fact, actually, I actually have this piece. By the way, this demo piece here, I just happen to have it. It floated by my desk, and I think I took it home with me, several months ago. And this one is, I think talking about the draft angle a portion of it. So you have this face here, and all these features are going to be made with one side. So you see that the purple angle here. But it's interesting because when you think about undercuts and draft, you see the blue. So this feature right here is actually drafted opposite of the outer wall because it's being made on the other side of the tool, which is some of those things that instantly become available when you use these analysis. You're like, boom, this feature will have to be made with these other features on this side, and it's something that just will instantly be indicated by color.
And typically, draft is so minimal that you cannot see it by the human eye. So every injection molded part around you probably has draft on it. So oftentimes, we have the concern of like, oh my gosh, is this going to affect my design? Maybe in some situations, if you have a mating part that's really critical, maybe a sealing surface, sure, it might influence that. But typically, this has no effect on your design if drafted properly.
Yeah. So now we're gonna move the mic to Kyle, because we have this uniformity undercut draft, which is something that as you're designing, it should just always be in the back of your mind. But then there's a conversation that you usually have with your mold team, like the team at Zometry here, which is I'm going to say we call it the PEG report, right? Party ejection and gating. So tell us a little bit more about that.
Yeah, so the PEG report is actually something that we do at the beginning of every project. We look at the parting line, the ejection, and the gating strategy, which is what we'll cover here in the next few slides. So the parting line and shutoff, this is actually where the tool halves come together. So the core and the cavity meet, and there's sometimes a little visible line that's represented on that parting line. To Greg's point there earlier, he had the part in his hand. You can't sometimes see it because it's usually buried on the bottom side of that part. But as you see the side there, if you look at the image on the bottom right, that red line is the representative parting line, and it kind of jogs up, and it jogs up in order to capture that little ledge on the part. You can sometimes see that parting line there, but we try to hide that and blend that as much as possible so you can't see it. At the same time, these parting lines, you can sometimes have little excess bits of material, otherwise known as flash, just where the material kind of seeps into that parting line. But again, parting line is something that's done in everything, core in the cavity. So the E in the PEG is the ejection strategy. Whether it's ejection pins, it can be done through hand loads, through automation. There's a couple different ways you can actually remove the part from the tool. But the purpose and the function of the ejector pins, they actually push the part out of the mold. So this is the only way to get the part out. To Kyra's point about the draft, the more draft you have, the easier it is to push that part out of the tool. The less draft you have, sometimes the more pins you have to get that part out, and more pressure to do that. Typically, there are little circular features, as you see there to the image to the right, little orange circles. Those would be all of the ejector pins on this particular part. We're not limited to circular features. We're not limited to just pins. We can also do blade ejection, which would be usually done on ribs, or in this case, there's also ejection done on the bosses, which is kind of hard to see in the picture, but it's a little light green areas on those bosses. So again, we're going to try to put as much ejection onto that part to help get it out of the tool as quickly as possible. And this is also done on the non-cosmetic core side of the tool.
Yeah, and something about ejection is we have these pins are not just to remove the part, but it's to remove it evenly. So you want to have even pressure across the part, because seconds ago in this cavity, it was liquid. It was liquid plastic, and it's still cooling. So if you had uneven pressure on the part as it's removing, you could actually kind of poke a ridge into the part as it's ejecting. So being liberal with ejector pins, like on this part, for example, is pretty common in order to make sure that it has an even push, even pressure across the part, so there's no deformity that happens as the part is still kind of malleable. So as it's still cooling and finishing up its cycle, so it'll drop into a bin after it's done, and it'll cool off. But that'll help mitigate any deformities there. And sometimes you'll see like little circles added like between ribs and other features too, where there's pins there. But again, it's very common. If you look at what we call the ugly side of any plastic part, you're going to see those little circles. They're going to be available.
And it's important with all of these, with the parting line, the ejection, and the gating, to communicate, because if you go back to the parting line, there may be a cosmetic side that if we have that parting line jog, you don't want to see that there. Same thing with that ejection. If we're trying to eject off of something that's a sealing surface, we don't want to put a pin there. You wouldn't want a pin there, because to Greg's point, it may leave a dimple there, and if it's sealing, then you lose that sealing ability. Same thing with the gating we're seeing here, the gating strategy. The gate is where the plastic that is in molten state is actually injected into that cavity side of the tool to fill the tool. Usually one of the most common gates that is used with our industry, with low volume or even non-low volume, is an edge gate. It's a small gate, small basic blemish on the outside cosmetic side of the part. In this situation here, because of the geometry of the part, customer requirements, we actually were able to gate onto the inside of the part. So this is actually done with a sub gate into just a little small post that helps fill the part from the inside of the part. So, normally it is on that cosmetic side, but, because of certain geometries, maybe cavitation or material, we're limited, but we also have some other abilities. In this case here, we can actually hide any sort of gate blemish. There's also options with higher cavitation production tools to go with hot drops, which kind of help to reduce scrap, which can actually lower your piece price at the same time, because we don't have as much loss with each shot of plastic.
Yeah, and so you'll know when you see like something that has like this hot runner gating system, because you usually see on that part a little dimple with a tiny little kind of nub in the middle of it, and that's a sure giveaway that that's the type of gating system to use. So something like this, where you see a small blemish, it's probably there's probably a leftover runner that is on the part that is removed before it ships to the customer, and that's usually done with die clippers or some other trimming feature.
Yep, there's typically some small little vestige left over.
Mm-hmm. Yeah. We try to mitigate that as much as possible, but it also depends on the material choice that you have, which we'll go into in a second here. But everything combined, so your geometry, your material, and the production method that you're looking for, all that helps us determine what's the best approach for your project. Speaking of that, we have requirements, right? So like some of it is just not just the CAD geometry. It's not just how the part's designed, but what other needs are you do you need to communicate to get the successful project? So the last 4 of these 10 that we have are the 4 requirements that must be communicated with your molding team. And by the way, spoiler alert, when you're working with us, this is part of our checklist. This is part of the Zometry experience. Is we walk through this with you, and we're here to educate and help you if it's something that you're not familiar with, because we want to make sure that when you get parts that you're getting what you think you're getting, we're making what we think you want, what you think you want, and we're all on the same page together. So we're here to make sure that that is technically communicated and kicked off well. So yeah, Kyra, like, when we talk materials, when we talk colors, like when does that conversation start?
Absolutely. So that starts early on. We want to make sure that we have the color nailed down and the material for that matter before we even quote this for you. Because of course, with every different material, there's different pricing that goes into that. There's different properties with every material as well that we want to make sure suits your application. Now, of course, the material decision is ultimately up to you as the customer, but however, we can make recommendations all day long, and but ultimately you know more about the application than of course any of we do, so we always want to make that clear. In regards to our material selection, we actually don't have a standard list of materials in stock, but however, that does work to our benefit very often because we're actually able to custom order the material based on the project. And even if it's a specific material, we can do that as well. So we are not limited at all to what's listed on our website. In fact, we have generic materials on there just for that matter. We are able to source any material out there as long as it's commercially available in the manufacturing location. So that is a huge advantage for us because we do deal with a lot of different applications and projects on a daily basis, and ranging from aerospace to medical, oftentimes there's different material requirements in there. So and of course, we can color match. So we can color match within a few shades. If you just send over a Pantone RAL code or even a sample plaque that you want us to hold at the machine, we can color match very close to what the requirements are. So with materials specifically, oftentimes we typically just quote general materials, right? Unless something else is specified. At the time of order is when we can provide a data sheet because we know what material we either do have leftover material of or what material we can order based on the partner that this project is sourced with. So the project is not sourced with the partner until the time of order. So that's why, at that time we can nail down all those details too. So, and then, of course, thinking back to that earlier slide when Greg talked about just injecting plastic into a mold, it's really simple, right? Well, every different material has its own shrink rate, and it affects to heat differently. It needs to be pushed a little harder. Maybe nylon needs to be pushed a little bit harder than, polypropylene or Delrin or something like that. So they do have different requirements, and it is very important to understand what the material is up front. So one, we can get you an accurate quote, and two, making sure that it does work for your design. And of course, you guys have anything to add to that?
I was going to say, yeah, it is really important to get that nailed down, especially shrink rate, because some similar families of materials, they may have the same shrink rate, and you may be able to get away with some of that, but it's not recommended. But different material families, if you're using the same tool, cavity, and you're changing materials in it, the outcome will be different. Just because it's what happens. What happens when material is in a hot state and a cool state? They have different properties to them. The other thing to note is, as Kyra said, we don't have, this is Xometry's ABS and this is Xometry's polycarbonate. We're usually getting to order based off your needs and specifications. We also use some great tools, and these are tools that are available to you as well, like UL Prospector, to help find some materials, and it helps kind of narrow down that search. Sometimes we find exactly what we need, and that's what we're going to source for you. If you are looking for alternate materials, or you have an exotic material in mind, we do high temp materials. We mold things like PEEK, we mold things like PVC. So we have a lot of options because we source for your project needs. Like we source for what's going to make your project most successful.
Absolutely.
All right. And on tolerances, so when does the tolerance conversation come up in this? How early do we talk tolerances?
Honestly, everything that we've covered, I like to talk on as early as possible. And that's just simply because, sometimes the DFM stuff comes up later on, right? After we already talk about pricing. But tolerances, we do want to recognize this early on before we do quote, just because, it's not going to add to the initial investment of the tool, but this could be a factor that contributes to some pricing down the road. And what I mean by that is if there is a tolerance that's tighter than our standard, and I'll cover that in a second, but oftentimes it requires further tool grooming to really get it to the proper state and what tolerance that is. So depending on the tool work that goes into that, that could be an additional cost later on. So to back up a little bit, our standard tolerances, we hold the molder to cutting the tool at plus or minus 5 thousandths, so the machining aspect. And then of course we allow for 2 thousandths of variation in the plastic. So all in all, that's 7 thousandths total. Which is an improvement for where we've been. We actually, our standard tolerance used to be plus or minus 10 thousand. So we've brought it in there because we've understood our capabilities. We've understood that we can hold, and oftentimes do hold, way tighter than that anyway. So we did bring that in a little bit. And on top of that, our part-to-part variation is very low. Once you cut the tool and you don't adjust the process anymore, it's pretty repeatable. That's just the nature of injection molding. So, and then getting back into the tighter tolerances, if there is something that's tighter than our standard, we will do our best effort at the time of the T1 samples or the first 10 good parts off the tool. And then any further tool grooming or anything will be an additional expense later on, and that could be calculated at that time, just because we don't know the initial work that's going to go into it based on how close we get it the first time, which oftentimes we're pretty close. So anything else on that?
I know you mentioned T1, and sometimes we throw it out without too much definition there. So those T1s you're talking about, those first 10 parts. So what is that timeline usually look like? And then we'll loop back in the tolerances. What does grooming look like if a part needs to be groomed? So yeah, when did I get my parts when I press order?
Sure. So the T1 samples, like I said, are the first 10 good parts off the tool. If you order quantity 1,000, we're not going to send you 1,000 parts up front because, there could be something wrong. So we're going to send you 10 parts to confirm, form, fit, and function. And then once you send us your approval on those, we'll continue production. So lead time on that, it really depends on the part geometries as well as the manufacturing location. However, I will say overseas is sometimes a little bit quicker than the US, depending on the production schedule and what they have going on. But an average tool, with simple geometry, maybe a couple undercuts here or there, typically falls between 3 to 5 weeks. So 15 to 25 business days for that matter. And that's to get the first parts in hand. And then of course, upon approval, we typically allow for an additional 5 to 10 business days to get the remainder of those parts. And of course, that depends on the quantity. So that's what the lead time looks like. Now, grooming of the part, Kyle, maybe you can speak a little bit more to that. If we do our best effort at the time of the T1 samples, we get really close, what does that look like grooming?
It really depends on a couple of factors. Ideally in a situation where if we've had communication up front about tolerance, this is a critical feature, this has got to be held to this, or maybe the something along those lines, we can leave that tool in a still safe condition to where we can basically dial in that tolerance. So we're just removing steel from the mold to give you that tolerance that's required on that feature. That kind of time frame is usually within a few days. If we have to go in and add steel, that's a lot harder, obviously. We're talking welding, remachining, re-EDM, whatever the case be. That could easily tack on another couple of weeks after those initial samples to achieve all of that.
Yeah, and as Kyle said, so we're talking steel safe, and this is because you are making you're making these tools, and we're making the cavities that the plastics are going to go into. So a steel safe condition is when we could adjust the tool by removing material. So we're just cutting. We're not welding back in. So if I have a part and it has a hole feature to it, I can. I'm gonna mess this up in my head here, but I can, a steel safe is because I'm gonna be using a pin essentially to plug and make this feature here. So if the hole needs to be smaller, then I can usually trim around that, and the hole could be smaller. But if it is something that actually the hole needs to be larger, I would either need to change out that pin entirely, change the core pin there, or be fancy with some welding and kind of weld up and build out. So There's certain grooming that is easier and kind of expected. So from a toolmaker standpoint, you try to keep things in that steel safe condition so that you're essentially benching up the tool piece and cutting away in order to adjust it to dial in those tolerances versus going the other way around and making metal essentially.
Exactly.
So, we're talking about these T1 samples, and I know a lot of times people were asking like, okay, so I have my part, I have my color. Why is my sample shiny when I want it matte, right? So, let's talk part finishes and textures and kind of what that looks like from I'm scaling up, I'm moving to, a part where I need to have like a nice, matte texture on the top there.
So a lot of what obviously Xometry does is custom. Finishes and texture is to that same extent. We're not locked into 2 to 3 to 4 specific finishes. We can custom blend, custom match. Have specific areas that are polished and other ones are textured. So what, first of all, a texture or a finish, this is obviously, what the part's going to look like. It's a shine, it's a texture, it's maybe non-cosmetic and you don't care what it looks like. But it is basically the cosmetic finish on the part that is obviously applied to the tool. So whatever texture's on that tool then transfers to the part. A lot of times, like if you see the blue part there on the screen, but also the same part that Greg holds, it actually has a real light finish to it. If you look around your desk, your phone, your laptops, your monitor screen, a lot of them have just a real light kind of a finish to it. That's a bead blast finish that gives it that matte finish, and there's usually a couple of reasons why people do that. One is because they don't want shine. Maybe the other is to actually hide some slight imperfections. Sometimes there's ribs on the bottom side of a part that maybe goes outside the traditional standards, and it is required for part geometry, but it leaves a little sink mark, as one of Kyra's earlier comments. So a lot of times you have a sink mark. It's really not the worst thing in the world. Texture the tool gives that part kind of a matte finish, and it actually hides that imperfection. It's still there. It doesn't eliminate it, but you can't see it like you could when it's shiny. The worst thing to do is to polish a mold, because then it accentuates that sink.
Yeah, so this one's a really good example. In fact, actually, if I hold the light just right, you may be able to see this ring right here, which is basically the only way in which you can see this ring, because this part has a coarser mold texture. So this is a secondary texturing that actually the tool is sourced out, almost like you would do finishing services on a CNC part to apply this texture. But the sink is created by this internal ring. So as this part cooled, that plastic kind of pulls in and tries to tug at this kind of cup shape here, and it ends up pulling and creating sink marks around here. But with that matte texture, it's almost invisible by adding that matte finish to it. So matte is very good at hiding some of those features, especially if you have something that is, has pretty beefy ribs on that side. It helps kind of mitigate the cosmetics of that, and hides fingerprints and other stuff too, which is nice. Yeah.
The other thing that's actually nice that you can do is, if you look at the picture there, it has a remove basket. You can actually have those areas polished to help bring that out if you want to actually show a label surface or again, text, things like that. But we're not again, as I mentioned, we can also go out and get specific texture. So we do work with mold tech shops, so we can actually send a mold out to be textured. But typically, to Greg's earlier point, we actually want to sample the part first. We're going to want to sample the tool to make sure that it's correct. The last thing that we want to do is send a mold out to be textured, to get it back, to sample it, to find out that there's an issue. We have to then go in and weld and then send that mold back out to be textured. So a lot of times you're going to get a part in that has no texture. We want you to sign off to say, yes, it's great, it's perfect, and then we're going to go out and texture. It's just something to consider in the overall timeline.
And just note, because we were talking about the mold texturing is that outsource SPI textures. They can most of the time be done in-house. The exceptions may be these A1 and A2 finishes, which is going to be like A1 would be like my glasses lens, like, you know, highly polished, optically polished. But A3, that level of polish, and then B1 to C3, those are typically their sand or kind of stone ground finishes, and then these D1 to D3 are different grits of bead blast. So again, you can take that tool or take that feature and literally apply the texture to the metal, and anything on that metal that's textured, when the plastic gets molded around it, that's what the texture of the plastic is going to be. So the more matte you make it, the more matte your part's going to be. So all this conversation, like I said, we have that, you know, we have the uniformity undercuts draft, we have parting, ejection, gating, so, you know, stuff that's going to happen to your part. Then we talk about our tolerances, we talk about materials, we talk about colors, we talk about texture, and then this is, you know, this is where it all comes together. So when we kick off the project, like, all this comes in play, and, you know, number 10 here, the project and tooling approach. So Kyle, like, what is the mindset? So you have this information, what else do you have to ask?
You know, it's funny because I think this is probably one of the most overlooked things with programs. You know, you get into the part details, you get into the part geometry, and you lose focus, you lose sight on some of the things that you need to know for long-term success. Again, tool life. Tool life is probably one of the biggest things where, you know, if our standard quote has a tool life that someone selected at 2,500, but you need 5,000 parts a year, obviously that's not going to work. So, you know, having that clear communication of how many years you need to have this tool run or this part produced, it's so important so that we can properly build a tool and quote a tool that'll meet your need. You know, again, annual usage, because, you know, if the communication is great on the front end, we can be ready for when you do need to have parts. If you have a quarterly requirement for production, I need 5,000 parts a quarter, you know, we can start planning and work with you to meet that requirement that you have. The mold specification, you know, the origin, you know, we do manufacturing both in the US as well as overseas in Asia. So we have to account for that, you know, with shipping if we go to Asia. You know, if it's US, maybe there's certain requirements for ITAR or something like that we need to meet. So, you know, just knowing that upfront communication, again, it's key. When do you need to have the parts in hand? You know, again, if we start looking at a calendar and you say, well, I need to be in production by October 1st, you know, we need to start planning backwards to say, well, you need to be into the tool design by September 1 or earlier, so that we can make sure that we can have success in hitting that production date for you. Mold material, again, going back in the tool life, if it's a P20 steel to get you 50,000 parts, or we need to go to an H13 because you're going to run this tool for 10 years, you know, we need to know that early to help you out. Hand-loaded tools versus automated tools. There's kind of a good graph over there. Obviously, for hand-loaded tools, the price of that tool is reduced, but your labor rates are increased because you're having an operator stand at that press to pull that loose piece. So it's a little image there on the right too, just outside of that. It's got two little pieces off to the side. Those are actually hand loads. So every time that mold open and closes, someone's got to sit there and pull those parts off the tool, which just adds cost to the parts. So if you're running a low quantity of parts, if you only need a few hundred parts every time, that's a great way of getting you, you know, an inexpensive tool, maybe a slightly higher piece price, but it'll suit your needs. Or if it's the opposite, if you're needing, you know, tens of thousands of parts, we want to go to more automated tooling so that, you know, the tool price may be slightly higher, but that piece price is going to be reduced.
Yeah, and by the way, the automatic also means overnight production, right? So we have you just have that throughput. You don't need someone standing there, you know, watching and doing a manual manipulation per part. So to talking about that tool life, that estimated use, you know, some of it is just down to if you need this many parts per week or per month, like, we have to go this approach. You know, we have to add this, you know, extra cavity or 4 more cavities to this. So So these conversations are really important to kind of scope out that need. And I do want to say sometimes to hit those tight deadlines, but also meet the overarching goal. Something that Zometry's done, especially in the past few months, we've seen this a lot, is we've done a bridge approach where we've had a tool that is a single cavity, aluminum, let's make this quickly tool. In the meantime, a longer term tool that's going to be replacing as a full scale production is also being made in parallel. Because we have this diverse network and we have all this parallel capacity, we're able to work those parallel jobs very well.
Mm-hmm. Absolutely.
All right. So yeah, guys. Again, I've seen a few questions come in. Please use the question tab to get your questions ready. I'm kind of excited because we have some time to talk through some of the Q&A here. The biggest thing for this is, we're versed in a lot of different approaches to making your project successful. We're not confined into like a small box of saying this is what we can do. Kyra is here to listen and consult, and Kyle is here to kick my butt when I overpromise something here. But he's he has amazing technical aspect, and he'll reality check on what is needed and when for this. But we really do have this have it your way approach, and I know this is Kyra's go, so I'll let you go on this. But like this is the molding with Zometry approach that we have. Oh, you're muted.
Thank you. I just noticed that. Right. So with Zometry, we want to have the have it your way approach. And just to back up here, everybody knows we're working from home. I try to mute myself as much as possible so my dogs aren't crazy in the background. So I apologize. But molding with Zometry, we do offer the have it your way approach. And what that means is we want the design as close to your original thought and your original intent as much as possible. So, if you're working on prototyping a lot, you've nailed out a design, everything looks good, but you need to make a little bit of changes here for manufacturability, that's kind of where we want to be. We don't have a small sandbox per se that we need to request a lot of different design changes to fit within that. We have utilized our partner network and our capabilities. I've said that a lot, but it's true. We utilize our capabilities across our network to understand, we can source, maybe partner A doesn't have this capability, but partner B does. Okay, let's go there. We're not limited in that percent. So that's what the have it your way approach means. And I already talked about material limitations as well. So as long as the material is commercially available in that manufacturing location, we can absolutely source it. So we are long-term solutions as well. We're not just prototyping. Our minimum order quantity is quantity 100. So we can go as low as that, but we can also offer, millions of parts. It just kind of depends on what your project needs and, utilizing that bridge tool option as well. So communication is really, really important to Zometry. It's one of our core values. And I say that because engineers like to talk to engineers. We maybe sometimes don't admit that, but it's true. We want to have that collaboration and we want to have that technical discussion that maybe somebody not versed in this field can't achieve. So I'm here on the phone to get all the information I can so we can, one, accurately quote it and to give you the best experience with Zometry. And that's just not limited to one phone call. I get on as many phone calls as I have to make the customer feel comfortable in working with us, so that is really important to us. And that's in addition to your main point of contact. So we strive for 24-hour quoting. Typically, your initial quote takes between 24 and 48 hours. And then on top of that, we also provide DFM feedback with that quote. And within the first 48 hours, the actual lead time, once you place the order, we offer that formal DFM and PEG report that Kyle talked about earlier. So way early on, we try to address those DFM concerns in regards to thickness, undercuts, and draft. And again, I said this before, I'll say it again, we do have a large partner network. We can go domestic or international. Typically, we default to international just because it is a little bit more cost effective, and normally that's a big constraint. But of course, if your project requires US manufacturing, we can absolutely source that too. And then, the real big benefit between us working with Zometry versus, maybe going overseas directly is Zometry is your only point of contact, meaning we manage the partner network. We actually have Xometry employees on the ground over there, ensuring that all of our partners, no matter what location they're in, are upholding the same standards in regards to communication, quality, expectation, all of those factors. Meaning that truthfully, if you were to order a project with us here in the US and another one with, overseas in Asia, you wouldn't know the difference between the two because we should deliver the same quality and the same communication. So we are your single point of contact. We absorb all those time differences and everything.
Yeah, it's like I said, it sounds too good to be true, but because we have this diversity, I mean, we're here to communicate and just make sure that your project's been successful. So, really get in early on with your project with us, because we're always a great resource, and we want to make sure that pragmatically you're taking the right steps to get you towards that goal. Definitely recommend checking our design guide again under Xometry's resources page. And I know I'm going to get to Q&A right now because I just saw several more roll in here. But if you do have FAQ, live engineering support, if you quote, by the way, you're going to find your sales contact really quickly because they're going to email you almost immediately. But we have several ways to talk to us, including live chat directly on Xometry site. And today, we are offering a deal. So we have a new mold order. So if you're working, in this next month here with a mold project and you're interested in trying out Zometry, we are offering $500 off the tool on your first mold order. So definitely look into this code, and as you're having that conversation, but it's something that we have open for this month here. So yeah, let's talk some questions here. And I know I saw a few come up, so Serena, I'll let you MC that.
Sure. Okay, so here's a question. Our team has outsourced injection molding to a company like yours, has considered outsourcing versus investing equipment and trying to do it in-house. Do you have any advice for trying to mold in-house versus outsource?
I guess the first thing to think about whenever you're figuring out if you want to outsource or purchase the equipment and run in-house is understanding what the ROI would be. Understanding what the quantities are that you're looking for. If you're looking to run millions of parts a year, maybe it is worth investing in a tool or in a injection molding machine. Typically those are pretty expensive, so I think that's the number one thing. But if you're only looking at smaller orders, then I think it would absolutely be worth it to outsource that, because all you're doing is you're sending a payment and then you're getting parts in hand. It's really that simple. If you're bringing it in-house, you have to purchase the injection molding machine. You also have to find somebody to build your tool for you. If you can't do that in-house, get it shipped to that, make sure it's designed for your equipment, and start the process, run the process, have somebody that knows how to do that. And there's really a lot of factors that go into
Source
that.
material, dry material.
Yeah, get all the equipment for drying the material. Plastics, a lot of different plastics are hygroscopic, which means they absorb water over time, moisture in the air. So you want to ensure that you have the proper equipment to do that, the material feed system. There's a lot of things that go into that. So I would say starting with ROI and understanding your quantities is the number one thing, and then working backwards from there.
Yeah, and obligatory plug here, but you could look at both routes. One of the beautiful things about us is we look at projects all the time. So if you do have that project in mind and you're trying to make that decision, share it with us. We're happy to show you, show our cards, and we could go from there.
Awesome. So the next question is, do you have a recommendation for very low volume production runs? In other words, less than 1,000 parts a year. So I guess any tips around going for that low volume run?
I could talk a little bit on this, and I know probably a couple others can touch on this, but just one of the costs you have to consider when you're talking about reorders is there is a setup fee involved with putting the tool up. So if you have 1,000 parts a year and you're like, hey, I need X amount a week, you may want to consolidate those into orders to have even like a minimal inventory in mind if you're taking an injection mold route, because of that setup fee. And it's something that you may want to incorporate into your part price. And a lot of times that's actually, we quote that incorporated into the part price. So it's just kind of absorbed in. So like a lower volume of parts may seem more expensive, but that's because it's including that tool maintenance, getting it up on the machine, running some shots till it's good, and then getting the parts that will deliver to you out of there. But it's definitely something to consider as well.
One of the things real quick on that is all the quotes that go out actually have that price breakdown. We actually provide future requirements, so we can maybe break it down into the higher quantities. So you can get a quote for 100, but in the notes section you'll see a price for 500, 1,000, maybe up to 5,000 to help make that decision for you.
Awesome. Thank you, guys. I just want to note that we'll probably do like 5 more minutes of questions. So keep them coming. And if we don't get to your questions, we will follow up, and feel free to reach out as well. So the next question is, can you do over molds or 2-shot molds?
Yeah, we can absolutely do overmolding. We're still working our way into 2-shot molding. We haven't broken that barrier down quite yet, but we can do overmolding and insert molding for that matter as well. We are very well skilled in both of those areas and can accommodate a lot of different designs, of course. Only thing that we require.
Even make the inserts. Yeah.
We do, yeah, we can even make the inserts and utilize our other divisions as well. That's a good point. Typically, if you want to quote an overmolding project with us, we do require a 2D engineering drawing as well as an assembly file just to show how everything's mated together, so we're not left to make any assumptions.
A little pro tip on that: a Parasolid file actually works very well for our system.
Sure.
And do we offer first article inspection reporting services?
Of course, absolutely. Kyle, maybe you can talk to the pricing end of that.
Yeah, a lot of it depends on what the requirements are. You know, how many parts you want inspected, but also how many dimensions on that part you're looking for. You know, we can do even beyond first article if you want to go to a CPK study or even beyond. But yeah, so we can, the 2D print would be ideal to show us what your critical dimensions are, so that we can check that. It could range anywhere from a couple $100 up to, I guess, a couple $1,000 if you're wanting a full PPAP.
I do see people starting to leave. I know we're at the hour, so I just want to remind everyone to make sure you make full use of that discount code, new mold order caps lock. We'll send it out in the follow-up email, and then these are the friendly faces you'll be talking to if you have further questions. So I'm just going to do 2 more questions here, and then feel free to follow up through email if you have more. Can you guys talk again about the typical lead time for domestic versus international?
Kyra, you want to take that?
Yeah, sure. I can start that. You can fill in too. So Kyle does do a lot of more of the work with the partners, so kind of understanding that firsthand. I kind of work more on the front end in regards to delivering that information. So with a typical mold, again, if it's in overseas in Asia, they default to a steel tool, which is a P20 steel tool. That one is really comparable to our aluminum option here in the US. Typically, those tools, lead time wise, are both, they fall within 3 to 5 weeks, not business days, 3 to 5 business weeks, which equals about 15 to 25, business days. So pretty quick turn solutions. With that being said, there is a little bit of fluctuation, you know, given what's going on in the world and everything. But right now, we're seeing that everything is running normally, and you know, our partners are definitely eager to take on more opportunities. Kyle, is there anything else you want to add?
Yeah, domestic wise, pretty close. It's pretty similar. We're usually in that 3-week stage. You know, we do I say on occasion, because of part geometry, we do have expedite options. So, you know, we have turned tools around in, you know, 5 to 10 days. It just depends on geometry. It depends on, you know, moon and stars kind of aligning sometimes to make that happen. But it is within our wheelhouse.
Great. And last question here. What is the most common material you see injection molded, and do you have any favorites?
Oh gosh.
I'll just say
We always have.
my favorite is polypropylene. There, I'm saying it. But
I do love polypropylene.
you're
I
so
would say
forgiving.
ABS. ABS is really common. Polypropylene nylon is very common. Typically, a lot of your commodity or engineering resins are really common, and we see a lot of those on a daily basis.
I think in my professional career, I used a lot of nylon, like glass fill variants nylon, and it's just, you know, very functional, very chemical compatible. It's nice material. But I've seen polypropylene provide miracles when it came to sink mitigation and some other things. The only problem is, you could dent it with your fingernail, but it's a fantastic material
Yes.
for a lot of applications, especially things around food and
It's
cleanability.
Yeah, it's also actually really easy to process too. Actually running the equipment, I loved running polypropylene.
It's
Nylon was
cheap.
considered the devil's material because it was really hard to manufacture in some cases, but once you got it down, you're good.
All right, well, that's it for our Q&A and for the webinar. Thank you everyone for joining. Do you guys have any last words?
The only
New
thing
mold
I would,
order.
yeah, that, and just if you know you're moving to injection molding, feel free to start that conversation early. It's going to make everything easier on the back end.
Awesome.
Thank you.
Guys, thank you so much for attending, and yeah, this has been great. Thank you so much. All right,
Thanks,
have a good
guys.
one.
Thanks, everyone.